Hi, my name is Eric and welcome to Cafe Calculations. Today we're going to be working on the average rate of change. This will end up becoming the building blocks to half of the operations in calculus known as the derivative. So without any further ado, let's start the average rate of change. When we're talking about the average rate of change, it's important to understand one main concept. That when we take the average rate of change, it is actually just the average rate. It doesn't give us instantaneous rate of change, which is why we shift over to calculus. So when we're discussing the average rate of change, let's consider a very basic function, something of this. Okay, we'll label that f of x. On the f of x, we're going to have 2 points. Let's start at the beginning and we'll start at the end. And if we drop down an x value and a second x value, then what we're going to do with the average rate of change is we're going to end up connecting a dotted line, to the best of our ability, through the 2 points. And when we do the calculation, it's going to smooth out these curves that the function is not on the dotted line and generalize it and average this thing out. But if we want to get particular rates of change at a point, that's when we shift over to calculus. So let's keep going. So we're going to define the average rate of change as delta y over delta x. Now let me just remind everybody, this little triangle thing here we call delta is actually standing for delta anything means final minus initial. So let me use it as an example with the y here. Delta y is really equal to y2 minus y1. And these little subscripts at the bottom are just labels. They do no mathematical power at all. And we have the same thing for the delta x. So if we kind of just expand out this equation, we get y2 minus y1 over x2 minus x1. Now this should look a little familiar to you as something you may have done in algebra, pre-algebra, algebra 1, algebra 2, and you do it in pre-calc and calculus and you keep doing it. This is basically the slope. We're looking at the rate of change of this dotted line between these 2 points of this function. And what we end up getting is just a smoothed out rate of change between these 2 points. And that's how we define the average rate of change. So now let's describe some points. Let's do an example on some of this stuff now with some points that were given to us. So here's an example. Let's take the point 0, 2, and we'll take the point 3, 4. And let's calculate the average rate of change between these 2 points. Well, we stick it in our equation. Average rate is equal to y2 minus y1, so we'll take the further y, 4, minus the second y, or the first y, 2, over the second x, 3 minus 0, which when we do the calculation, 4 minus 2 gives us 2 most of the time, and 3 minus 0 is 3. Therefore, the average rate of change between these 2 points is 2/3. Once again, this should be reminding you of slope when you first studied linear equations. And that is the average rate of change in this example. Thank you very much for watching Cafe Calculations, and I hope to see you very soon in our new episodes. And remember, enjoy the process.